Hello, my name is Colin Hall, and today I'll be going through my compliance testing procedure for the current of our force sensor circuit. So I've gone ahead and skipped step 1, which is plug BioPack MP35 into a 120 volt wall outlet. This is the BioPack over here, and it is plugged in, but the plug is underneath my desk, so I will not be showing that. I've also skipped step 2, which is plug circuit into the BioPack via a DB9 plug. That is this gray cord you see on screen. It has wires coming out that connect to the circuit, and over here it is plugged into the BioPack. Moving on to step 4, confirming all the connections are tight, we're just going to push these wires in one more time from the DB9 plug and just make sure that that is all secure. Also make sure the components are all in and nothing is loose or out of place. Moving on to step 4. The BioPack is turned on already, so we have kind of skipped step 4 as well, and the circuit is powered by the BioPack, which includes the sensor, which is this thing here. I don't know if you can see it that well, and the op amp, which is, if I try to clear some of these wires out, this right here. I don't know if you can see that all that well. Moving on to step 5, we have our SparkFun digital multimeter right here. We are going to move this little lever to the 20 volt measuring setting, and then we are going to measure the voltage from the input wire, which is this gray wire. I'm just going here off the resistor so that it connects, and the ground wire over here, and right, which is the red wire here. I don't know if you can see that all too well. It is here. I'm using red to show red. Maybe I'll go. It's this wire here that I'm touching right now. Since they're both plugged in already and I don't want to unplug them, I'm going to measure from here to this other resistor right here. Actually here. I'm going to measure from this resistor wire right here, which is connected to the input wire, and this little wire right here, which is connected to ground. Yes, it is across resistors, but this step is purely to show that the circuit is getting power. And I do that like this, and I'm getting a reading of, here we go, that will show the reading better. There. It's going to be backwards for me, but it will be up, the right side up for you. We do that, and we get a reading of 4.98. So the circuit is powered, and we have just proven that. Moving on, we are going to take this SparkFun digital multimeter and turn it all the way down to the 20 milliamp measurement setting, which is right here on this multimeter. We set this down again, and we measure while there is no, get that wire out of the way, and we measure while there is no force on the sensor, which is here. So placing my one lead here where the circuit is powered on to the output, which is actually down here in the strangled mess of a voltage divider. That's gonna fall. So down here we have a voltage divider that is made up of two 1 kilo ohm resistors in series in parallel with two 4.7 ohm resistors in series. So a total of a voltage divider made up of a 2 kilo ohm resistor in parallel with a 9.4 kilo ohm resistor. And that's actually better set up. I'm gonna go like that, and I'll lift that up for you. I'm gonna place one lead here in a way that it touches and will remain there, and then I put the other lead down here on the output, and I get a reading of 2.64 milliamps through the circuit, which is well under our target of 5 milliamps. And I'm going to do that again, but this time making sure, if I can pinch that right there, this is going to be tough. Holding this, you can see, oh, that's why it's jumped up. Come on. Come on. This experiment requires multiple hands. So we still have our reading of 2.64 while resting. Now what I'm going to do is I'm going to, come on. Okay, 3.04. It has gone up, obviously, because the circuit is going to be oscillating a little bit. 2.64. Now that we have that, I'm going to apply a force to the force sensor. Now I'm squeezing down relatively hard here to simulate a weight of roughly 20 pounds of force, like they would experience, like the sensor would experience from someone using a wheelchair. And what you'll see is we get a reading at 3.10 milliamps. Again, so even with the force applied, the sensor is well under the requirement. The sensor circuit is well under the requirement of 5 milliamps. And that is a video demonstration for this compliance test. Thank you.